everyone. My name is Ankur Dixit, Assistant Professor in Mechanical Engineering Department of ABES Engineering College. In continuation of our lecture series of internal combustion engine, this is our second video in which we'll be focusing on classification of internal combustion engine. So it will be all about the entire internal combustion engines classifications, on what basis and on what category we are classifying it. So then the entire content will be based upon the classification of internal combustion engine. We'll introduce first on what basis it will be classified, and then continue with the further classification. So on what basis the internal combustion engines are classified, even though that the basic parts are the same, design differences can change the way the engine operate and how they are repaired. So this is the major point, that all the basic parts generally of the engine are same, but the design difference between them that can change that how the engine operates and how they are repaired and maintained. So this is one major basis of consideration that by which we can classify the internal combustion engine. This is the reason that we must know how to classify that internal combustion engines. So based on these factors, there are certain categories such as, first of all, cylinder arrangement, then number of cylinders, how many number of cylinders are there, what is the cooling system type, the valve location, where the valves are located, and where the camshaft is located. So these are the 5 categories on which we can categorize we can classify the internal combustion engines. Other than these 5, there are other 6 too, based on the combustion chamber design, based on the type of fuel which is burned on it, based on the type of ignition, which type of ignition is done, based on number of strokes per cycle, number of valves within that cylinder or within that engine per cylinder, how many number of valves are there, and based on the types of aspiration, what kind of an aspiration is there. Aspiration which classifying the internal combustion engines. So let's pick up the first category, cylinder arrangement. Yeah. So cylinder arrangement, what cylinder arrangement as a category is, that means it refers to the position of the cylinders in relation to the crankshaft. What is the position of the cylinders or cylinder blocks in relation to the crankshaft or in relation to the crankshaft? Okay, so I'll depicting it with the pictorial depiction or a moving animation. So on the basis of position, there are 5 basic cylinder arrangements. First is the inline arrangement. Second is the V-type arrangement. Third is the slant arrangement. Fourth is the W-type arrangement. And fifth is the opposed cylinder arrangement. So we can apply these cylinder arrangements based on the position of the cylinder. So here you can see all these pictures are generally depicting either 4 or 6 or 8 cylinder engines. So the number of cylinders I am varying, the first category which is varying is the number of cylinder. So you can see in inline cylinder arrangement, there are 4 cavities or 4 cylindrical holes. So in this, the pistons are placed. So these are in continuation in series inline. Okay, so the cylinder blocks, all the cylinders are arranged or positioned in relation to the crankshaft in a single line. This can also be done by line arrangement by this animation. So this is an inline engine. What you can see, that all these pistons which are reciprocating within the cylinder block and the 4 cylinder liners, they all are connected to one connecting shaft, and the angle of connection is entirely 180 degrees. So all cylinders are in one line. See this, I'm depicting it in a line. And they are connected with the crankshaft in one single sequence. Whereas a V engine has the cylinder arrangement at the angle of 120 degrees among them. So this is a V6 engine animated depiction. 3 cylinders are arranged on the left hand side of the V, and 3 cylinders are arranged on the right hand side. So you can observe that three cylinders are reciprocating on the one side of V, and second other three cylinders are rotating on the other side of the V. And both the engine sets, three sets, are making an angle of almost 120 degree, and they are arranged on a single crankshaft. So the position of the cylinder with respect to the crankshaft is inclined. And that's why this inclination angles of 120 degree makes the V engine. The another engine is opposed piston engine, the another type of cylinder arrangement. In this, the cylinders are actually at the angle of 180 degrees to each other. The cylinders are arranged. So the two cylinders, this is the opposed four-cylinder engine in which two cylinders are placed on the one side of the block and the other two are placed on the other side of the block, making an angle of completely 180 degrees. So this is a type of a horizontal engine. The position of the cylinders are horizontal, and also half of the cylinders and piston arrangement is done in the opposed direction. Okay, so this is inline arrangement, this is V arrangement, this is opposed piston. So by that we can classify that yes, this is an inline arrangement. V type, you can say the yellow part which I'm highlighting. This is the point of a crankshaft where the axis of the crankshaft lies, and the axis of the reciprocation of the pistons is depicted by these lines. You can see the shape here, the reciprocation of the piston, the point where the crankshaft is there, and the reciprocating part and connecting rod of the other piston part is making a V. In a similar way, this V engine is also sometimes replaced by the W engines where the number of cylinders increases. So here you can see this is actually a W engine, W type. So here are on a single crankshaft, the positions of the piston and cylinder arrangement has different 4 positions, and these 4 positions are in a W pattern. So this happens because we need to adjust the space within the same bonnet of the vehicle or a car, and we have a space limitations and the consideration. That's why we need to arrange the cylinder positions, because we need to arrange all the connecting rod on one crankshaft so that we can have the power from all the cylinders combined effect on a single crankshaft to attain the power on the flywheel and then further to the wheels. This was the opposed, which I have already shown in the animated video. And one is the slant type. In the slant type, you can observe that the connecting rod and the crankshaft arrangement is here, and the reciprocating motion of the liner of the piston reciprocating within the cylinder liner is at a particular angle. So this is a slant arrangement or a slant position of the cylinder with respect to the crankshaft. Inline, V-type, slant, double, opposed. After that, we can classify these engines on the other categories as well. This was the positioning or cylinder arrangements. Then based on the types of fuel which is used in an engine. So you might have heard saying that this is a petrol car, this is a diesel car, this is a CNG car. So these names or these classification of the engines or the cars has been based on the type of fuel. So based on the type of fuel, petrol engines are there. They are classified as petrol engine, diesel engine, gaseous engine, or CNG engine, just like that. And another category is the bi-fuel engine. That means a single engine which can use 2 fuels in it. For example, ethanol and petrol and CNG. All these types of fuel can be used in only one single engine, that is a spark ignition engine or a petrol engine. So petrol engine can use CNG as well as ethanol in it. Okay, so that's why bi-fuel category or the classification is there. Then the third category is based on the nature of thermodynamic cycle. Now, what is the thermodynamic cycle? It's our air standard cycle. I was also mentioning it about in our first introductory lecture that we'll be covering about the air standard cycle in the later series. So based on the thermodynamic cycle, we have Otto cycle. As a first type, Nicholas Otto has made a petrol engine working on an auto thermodynamic cycle. Then Rudolf Diesel has developed a diesel engine working on a diesel cycle. And then we can have a dual cycle engine or a mid-cycle engine. So which has the advantage of both auto and diesel, and it is a combination or a combined effect of an auto and diesel cycle. So there is also a dual cycle engine or a mid-cycle engine. So practically, auto cycle and diesel cycle engines are theoretical engines, but in practical, in real, the entire working and phenomena of an internal combustion engine happens like a dual cycle. We'll be covering it in a later stage. Then fourth category on which the classification of internal engines can happen is based on the number of strokes per cycle. So first is the four-stroke engine and second is the two-stroke engine. Two-stroke engines are now almost getting obsolete from the market. So two-stroke engines are not studied much. They are still used in the water engines. I'm saying the vehicles which are run in the seas, or it's just like the jet ski. So those are the two-stroke engines. In submarines, sometimes two-stroke engines are used because they have certain advantages over the four-stroke engine. But for the commercial applications, majorly the vehicles which you see over the road, most of the engines are four-stroke engines. And four-stroke engines have pretty good advantages over the two-stroke engines. The differentiation between the four-stroke engine and two-stroke engine, between a petrol engine and a diesel engine, we will be covering in the later videos. This time we are focusing on just the classification part. Now, the fifth category in which we can classify the engine is based on the method of ignition, that how you are igniting the mixture of air fuel within the combustion chamber. So, with the help of a spark, if we are igniting the air and fuel mixture with the help of an electric spark, then those types of engine are known as spark ignition engines. It is also called as SI engine, spark ignition, that is SI engines, in which mixture of air and fuel is ignited by the electric spark. And the second method of ignition is the compression ignition. That means the fuel is ignited as it comes in contact with the hot compressed air. So what happens that in this, the mixture of air fuel is not pre-mixed outside the chamber. The air comes first, it is compressed, and the temperature of air rises, the pressure rises, and based on that temperature, the heat which is generated after the compression, that heat is utilized to burn the fuel, which comes on the third stroke by the help of fuel injector in diesel engine. So all the diesel engine types are the compression ignition types. All diesel engines are CI engines, compression ignition, and all petrol engines are spark ignition engine. CNG engines are also ignited by the help of a spark. That's why they come in the category of SI engines. Okay. So the sixth category is method of cooling, that on the basis of what cooling method we are classifying the engines. So air-cooled engines, that means by the help of air convection. So air convection, this happens in the open engines, engine surface. For example, motorbikes, motorcycles, where the engine is exposed directly to the air. So larger amount of air comes in contact with the outer body of the engine surface. So engine is directly cooled to, or the heat is directly rejected into the air. But when we have the engine in an enclosed space, just like our cars, that engine is situated or it is located within the closed cabinet or a bonnet. So there we require the higher heat transfer rate so that we can reject the heat in the larger amounts. So water-cooled engines are required, in which the water jackets are provided. That is also based on the size of an engine, because the engine of cars are generally of higher capacity, they have higher volume on it. So because of higher volume, a higher heat is generated, and we need to reject higher amount of heat. So only air cooling, we cannot get dependent on the air cooling method. That's why we use water cooling. So there are air-cooled engines and water-cooled engines. We can also combine the effect of air cooling and water cooling in certain world tanks. Then the another category which is there is number of cylinders. So based on the number of cylinders, how many classifications can be possible. So first is the single cylinder engine, then dual cylinder engine, 3-cylinder engine, 4-cylinder engine, 5-cylinder engine. You can increase the number of cylinders, and by that the classification of engine changes. For example, the Maruti 800 car, which is very famous in India, that car was a 3-cylinder engine car. Right now, all the cars which are coming in market are generally 4-cylinder engine cars, and those 2, 3, 4, 5, as the number continues, they all come in the multi-cylinder engine type. But a single cylinder engine vehicles are also possible. For example, bikes, scooties, two-wheelers are there in which not the larger amount of power is required. So a single cylinder is able to generate that amount of power. That's why all those engines are single cylinder engines. And the engines which are used in cars, certain of bikes are there. For example, CBR 600, which are using 4 cylinders, and Royal Enfield, which are using 2-cylinder engines. So there are certain two-wheelers also which are using multi-cylinder engines. So how many number of cylinders are there confining all the volume? So the volume and the cubic centimeter, the CC, the capacity, I'll be discussing when I'll be discussing about the terminologies of the engine in my next video. Okay. The another category and classification comes on the basis of speed, that how much speed your engine can deliver. So there are low speed engines, there are medium speed engines, and there are high speed engines. So generally two-wheelers are considered as a low speed engine, two-wheelers of conventional type. There are many two-wheelers which are sports bike, so they are considered as a high speed engine. So it's a power to weight ratio game which has to be analyzed. But based on these speed, we can classify that yes, this car or this engine is a low speed engine, and the other vehicle or other car is a high speed engine. So in these ways, these are the categories by which we can classify the internal combustion engines. Thank you for that. These are the references which we have referred. Much is there only in the classification of the internal combustion engine. We'll continue about the other topics of internal combustion engine in later videos of this lecture. Thank you, guys.